Okay, set builder notation. So we just finished talking about roster notation where I list off all the elements in the set. Now we've got set builder notation, which is basically like some instructions to build my set. So I can put together my set based on some instructions that are given, and that can save me having to list off every element of the set, which can get long sometimes. But sometimes it's just as easy to go with roster notation we just learned. Kind of depends, but I want you to be able to do both and to go back and forth between the roster notation we just learned and this new set builder notation, which again is some instructions to tell you what to put in the set. Okay, I don't list them off, I just give you instructions of what goes in the set. Okay, now quickly before we do some examples there, I want you to learn some notation here. You'll see these in the book, so I want you to get used to these weird looking letters, and all they mean is just different groupings of numbers. So natural numbers, if you learned this way back, I don't know, but 1, 2, 3, 4, 5, etc. Those are called the natural numbers, and you could see this weird looking N in the book somewhere, so that's what it refers to. This weird W is whole numbers, which is the same thing except now it contains a 0. More interesting is the integers. That's got this weird Z. Not sure where they came up with Z, but integers is got the 0, 1, 2, 3 on the right, but it also goes negative 1, 2, 3, dot, dot, dot. Okay, and the R for the real numbers is basically every fraction, every decimal, all the counting numbers, etc. So that's the symbol for real numbers. So get familiar with these because you'll see these in the exercises. Then let's look at some actual examples of set builder notation. Okay, so I just called my first set A. Again, I can use any letter. So I'm going to call my first set A. And here's how I read this. I say any X or all X's such that X is a positive even integer. Okay, so these are like my instructions for what to put into my set. Here's the letter I'm just going to use for the elements in the set. All X such that X is a positive even integer. Okay, so, well, what does that mean? Let's maybe start with integers. So that's negative 3, 2, 1, and 1, 2, 3 positive. But it has to be the positive. So that means 1, 2, and 3 to the right. Okay, 0 is not positive or negative. So it has to be positive. So it's going to be 1, 2, 3, 4, 5, etc. to the right. Now it has to be even. And that means 2, 4, 6. So it's going to be 2, 4, 6, 8. Everything is going to keep going to the right to be positive, even, and it has to be an integer. So I can go back to the roster notation we learned and say 2, 4, 6, 8, dot, 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 10, 12 is going to continue, right? Okay, let's look at another one. B, all X such that X is an element of the natural numbers. That little E looking thing means element of. That means X has to be in the group of natural numbers. So again, I look up here, it has to be a 1, 2, 3, 4, 5, 6, etc. But now I can have as many rules or stipulations or conditions as I want. So I've got another one here. It says not only an element of the natural numbers, but it also has to be true that X is less than 5. Okay, so less than 5 means it doesn't include 5. That would be less than or equal to. So it has to be less than 5, lower than 5, and a natural number. So natural numbers only go down to 1, and it'll go up to 4 because I have to stay below 5. So basically 1, 2, 3, and 4. Okay, so as roster notation, it would just be the curly brackets 1, 2, 3, 4. Okay, C. I can use any letter I want, so I'm going to switch to N here. All N's such that the following is true. N is an element of the Z or the integers, so it has to fit into this grouping called integers, and it also has to be between -2 and 2. Now let's look a little closer. N has to be greater than -2. So it can't land right on -2. So it has to start up here with -1 is the lowest it can go. It has to be less than or equal to +2. So it can be equal to 2 or less than, so 1, 0, and the -1, but I had to stop at -1 because I can't hit -2. So basically, moving that to roster notation, that would be -1, 0, 1, and 2, right? Again, I can't go down to -2. I have to stay above -2, and I can go up to and including +2, okay? So be able to convert that into roster notation, and that's what we get there. Okay, finally, D. They can throw a little bit of a curveball here. They can say D equals all 3 times Z, or 3 times every Z, such that Z is a positive integer, okay? So again, there's just one condition here, and they take 3 times the Z. So I get all my Z's from this condition or this rule here, and then I bring it back here and times it by 3. Okay, so in roster notation, again, Z positive integers, up here positive, 0 is not positive or negative, so it starts with positives is 1, 2, 3, dot, dot, dot. And here it says take it and times it by 3. So 1 times 3, 2 times 3, 3 times 3, 4 times 3, dot, dot, dot. Okay, so this is your introduction to set builder notation and things they could put in there. Here's the equivalent, the equal roster notation that would match that. Okay, very, very good.